Hello everyone, welcome to the solution of LeetCode problem 11 named container with most water. In this problem, you are given an integer array heights of length n where there are n vertical lines drawn such that two endpoints of the ith line exist. Find two lines together with x axis to form a container such that the container contains the most water. And we have to return the maximum amount of water a container can store. Here, in the first example, the array length is 1, 8, 6, 2, 5, 4, 8, 3, and 7. Here, if we make the container using the second and the last pillar, it will contain 49 amount of water, or the volume is 49. Why it is 49? Because the minimum of both of the pillar is 7 and the difference of index number of both of the pillar is also 7. So here the volume will be 49 and the constraint are the height can be in between 0 to 10 to the power 4 and the length of the array can be in between 2 to 10 to the power 5. I hope you understood the problem statement. Now let's move on to the algorithm. Now, for the simplicity of the algorithm, we have taken the first example. Here, we can see that we are given total 9 elements or 9 pillars. And if we put the second pillar and the last pillar into consideration, then the water level is this, which is this. So here we can see that the difference of the index number is 8 minus 1, which is 7, and the minimum height of the pillar is 7. So the volume will be 7 into 7, which is 49. So here in this problem, we have to return 49 as the answer. So the question is, how can we solve the problem? We can easily solve this kind of problem by using two pointers algorithm. Here, the algorithm is pretty simple. At first, we will mark one pointer as the first pointer, which will mark to the first element, and we will get another pointer which will mark to the last element. Now, the algorithm is, suppose the first pointer is I and the last pointer is J. So here, in each iteration, we have to calculate the volume, where the volume will be difference of the index number multiplied by the minimum of the both of the pillar height. So here, suppose the value of I is 0 and the value of J is 8. That means I is pointing to the first element and J is pointing to the last element. So now we have to calculate the volume. So here the difference of the index number is 8 minus 0, which is 8. And the minimum height will be minimum of 7 and 1, where 7 is the height of last element and 1 is the height of first element. So here the minimum will be 1. So in this case, the volume will be 8. Now, it is one possible solution or the one possible volume. Now wait, as it is a two-pointers approach, we have to move our both of the I and the J pointer. So how can I move the pointers? The algorithm is pretty simple. If our current element I is greater than current element J, that means if we want to find the maximum volume, we should not move the maximum element pointer, right? So here, as A of I is greater, that means in this case, we have to move the jth pointer. So we have to decrement the pointer value j. So it is the greedy approach. And if our current I is less than current a of j, in this case, we have to move our ith pointer because the value of the ith pointer is small. So in this case, we have to move the ith pointer in hope that in future we will get into the another bigger value. Otherwise, if both of the a of I and both of the a of j are equal, in this case, we have to move both of the ith pointer and both of the jth pointer. And in each iteration of I of j, we have to calculate the volume and we have to keep track of the maximum volume accordingly. This is the algorithm. Suppose in this algorithm, here we can see that the value of I is pointing to first element and the j is pointing to last element. So here, the volume in this case is 8 into 1, which is 1. We have calculated earlier. So now we have to move our I pointer and j pointer. So what is the optimal way to move I and j? So here we can see that I is pointing to element whose height is 1 and j is pointing to element with height is 8. So here it is optimal to move the ith pointer, because if we move the jth pointer, it will not be optimal because still I will point to the smaller element. So here we will move the ith pointer into here. Now our current I is pointing to the second element where the height is 8 and j is pointing to the last element till now where the height is 7, and the minimum of 8 and 7 will be 7. So here the minimum is 7 and the difference of the index number will be 8 minus 1, which is 7. So here the volume will be 49. This is the maximum volume we can get. And now if we move the ith pointer in between any of the middle value, it is ensured that the volume will not become greater than 49. So I hope you understood the problem and as well as the example and the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named max area. Now we are taking two pointers. The first pointer I is pointing to the first element and the pointer j is pointing to the last element. And we are taking one variable named answer to take the maximum answer. Now we are using loop, and in each iteration, while I is less than j, we have to calculate the width and the height to calculate the volume, where width is the j minus I, height is the minimum of a of I and a of j, and the volume is width into height. And we have to upgrade our answer, which is the maximum of answer and the volume. Now, the main condition, if our current a of I is greater than current a of j, that means we have to decrease our j pointer, or we have to decrease our pointer who's pointing to the smaller element. Otherwise, if our current I is less than 2 a of j, that means we have to increase our ith pointer. Otherwise, if both of them are equal, we have to move both of the pointer. After that, we have to return the answer. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we are iterating each of the element, and the space complexity is big O of 1 because we are using only constant extra spaces to store the answer. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.